All right, so far we looked at rationalizing the denominator where there is one term, and the idea was pretty simple. You know how to make a number rational by multiplying it with something, and then you multiply the numerator and denominator by the same thing, so you are not changing the value. Now, consider two terms in the denominator. So our strategy is going to be find what we can multiply it by in order to make it a rational number. Okay? So consider 1 over root 2 plus root 3. Let's try what we have done before. Let's multiply and divide by square root of 2. But then we get one rational, but the other part is still irrational. If we use root 3 over root 3, the first part is still irrational, even though the second part becomes rational. So it fails. So we dig into our toolbox to look for something else. We make the following observation. Root a squared is a, root 3 squared is 3, root 6 squared is 6, etc. And a plus b times a minus b is a squared minus b squared. Or if I replace a and b by root a and root b, which are both irrationals or possibly irrational, I end up with a minus b, which is rational. So that's what we're going to use. So if I have to make the denominator rational, I multiply divide by root 2 minus root 3. So if this is a plus b, this is a minus b. Right? So this becomes 2 minus 3, which is 1 in the denominator. Let's look at some examples. So here I have 3 over 3 root 2 plus 4. I multiply by 3 root 2 minus 4 and 3 root 2 minus 4. So on the top I have 3 or 8 times 3 root 2 minus 4. In the bottom I have 9 times 2 minus 16, and that's 8, 3 root 2 minus 4 over 2. So I get 4 times 3 root 2 minus 4 over 1, which is a rational denominator. Similarly here, now in this case I already have the negative, so what I do is I use the positive version. It's always going to be the opposite value. So on the top I have to distribute this product. At the bottom it's just root 6 squared minus root 3 squared. So when I distribute, that's 2 square root of 6 plus 2 square root of 3 plus square root of 30 plus square root of 15 divided by 6 minus 3, which equals, let's see, square root of 30 is 2 times 3 times 5, so really nothing there. Square root of 15 is 3 times 5, so again nothing there. So 6 minus 3, you just replace this by 3 and that's the end of it. You can also have generic expressions where there are no numbers. So let's look at that example. X plus h plus root x over x plus h plus root x. So on the top, that's an h times root of x plus h plus root x. At the bottom, that's root of x plus h squared, remember, and root of x squared. So that's h root x plus h plus root x. That's x plus h minus x. Right? So whatever, the same thing in the numerator, but the denominator just has an h now. The process that we learned in case 2 has a name, it's called multiplying and dividing by the conjugate, where the conjugate of a plus root b is a minus root b and the other way around, meaning you change the sign. So if you have root a plus root b, the conjugate becomes root a minus root b. If you have root a minus root b, the conjugate is root a plus root b. In general, conjugates have very nice properties. We will revisit these later in this week's material. Even if you consider a plus b and a minus b, there's a symmetry between these numbers, as you can see on the number line. if this is A, this is A plus B, and A minus B, they are equidistant from A, meaning the average of A plus B and A minus B is A. Right? A is the average of A plus B and A minus B. If you add them up, divide by 2, you get A. The symmetric relation is going to keep coming up in the week and the week following that. Some examples here again for rationalizing. I multiply and divide by the conjugate, which is root y plus 3 root xy, root y plus 3 root xy. And then I perform the multiplication via distribution. Right, so that becomes 3 root xy plus 9x plus y plus 3 root xy. And this becomes root y squared minus 3 root x squared. Keeping the whole terms 9x plus y, combining the square root terms 6 root xy. This is y minus 9x. Similarly here, I have root a plus b over root a minus root b. Conjugate is root a plus root b over root a plus root b. Now on the top, what I have is root a plus root b whole squared. And on the bottom is root a squared minus root b squared. I can use our property for a plus b squared to get a plus 2 root ab plus b over a minus b. Again, the end goal is that the denominator is a rational number. Root 5 minus 1, root 5 plus 1 over root 5 plus 1. So that's 2 times root 5 plus 1. And this is root 5 squared minus 1 squared. That's 2 times root 5 plus 1 over 5 minus 1. That's root 5 plus 1 over 2. This is, remember, if you remember from exam 1, there was a problem where you were given x squared minus a plus bx plus ab. These values are actually a and b if you had completed the question. Okay, that's it for this video.